We are solving May June 2022 paper 4-1 question number 3. This is a straightforward question related to circular queues. Let's start. In the first part, we are supposed to declare the array, head pointer and the tail pointer. So what we'll do is we have to write the head pointer. We should always look ahead in such questions to see if they have any pseudocode given. So we'll use the same names. Here we have the tail pointer. So we should call the other one head pointer, and then we have the queue array. So head pointer would be an integer. Tail pointer would also be an integer, and then the queue array would be an integer array. So question says that you are supposed to declare these. So we will just copy this part and we'll paste this in the evidence file. This is declaration part. Now, when we have to initialize, we'll just write something like this. We'll have head pointer as 0, tail pointer as 0, and then 10 string values, empty strings in the queue array. Then we move on to part B. Part B says that this is the pseudocode that will write for adding the data to the queue. It returns false if the queue is full and returns true if the queue is not full and the item is added. So there are 5 incomplete statements. We are supposed to write the program code for this. Okay, let's start. First of all, the function name is called enqueue. The parameters here are queue array. Python automatically sends the objects as by reference, so we don't need to write that. Then head pointer. Then we have tail pointer, then we have number of items, and then we have data to add. I believe number of items, okay, number of items also need to be initialized to 0. So number items should be set to 0 like this. Okay, done. Then the question says, returns boolean. So we'll do it towards the end. Now, if the number of items is equal to blank, then return blank. So if number items is equal to, okay, we have to write this. Now, if we look at the statement here, that is adding 1 in number of items every time we enqueue a value. So when the number of items become equal to 10, which is the total size of the array, then that means that the queue is full or the array is full, and we're going to return false like this. Okay, otherwise they're saying that you have the queue array here, and at this specific index you are supposed to add the value. So data to add. Now the pointer that we add the value on is always the tail pointer towards the end, right? Okay, this is done. Then we are checking if tail pointer is greater than equal to 9, then tail pointer is equal to, okay. So when the tail pointer becomes greater than equal to 9 and we have some space in the queue, so what will happen? Let's say we have these elements 3 elements 3, and we have some value 5, 6, 9, 0, 7, etc. Let's say this is the last element. If we place a value here, let's say 10, so I can clearly see that there are 3 slots still left. So what I'll do is I'll pick the tail pointer from this last index and I'll move it back to the start, which would be index 0. That's what I have to do. I'll simply say that tail pointer becomes equal to 0. Okay, else if that is not the case, so if the tail pointer is not at the boundary yet, what you'll do is you'll simply increment 1 in it. You'll write tail pointer plus equal to 1. So if it is at index 4, it goes to 5, 5 to 6, 6 to 7, until and unless it doesn't hit 9 or becomes greater than 9, you're not going to wrap around, right? This is called wrapping around, which takes back the index to the start. Okay, this is done. Then we simply increment the number of items by 1 because we have added another value in the queue, and we are going to return the value of true here, and the function will end. Okay, now moving on to the next part. Now we're supposed to write the function for dequeue. So let's hide this part and let's go on to dequeue. So define dequeue, and in dequeue they're saying that we're supposed to return false. Now this false is a string because it's in quotation marks. If the queue is empty, or it returns the next data item in the queue. Okay, first of all we have to check if the queue is empty. Now how would we know the queue is empty? So again, if I draw some values, dash, dash, and dash, let's say we have 5 values and the number of items are 0. Okay, there are no values as of now. That simply means that the queue is empty. That is why we have the number of items variable in the first place, which is tracking the number of values that are present in the queue. So global let's access all the values, and I'll simply check if the number of items are equal to 0, then that means I will return false. Again, this should be in quotation marks. Okay, if the queue is not empty, then we are supposed to return the next data item in the queue. So the same logic has to be done as we did here. We have to check if the head pointer at any points becomes greater than 9, then we are going to wrap it around and we're going to bring it back, right? Same logic. So let's say you have dequeued 7, 8, 9. So these are the values that are empty right now, and you have dequeued 7. Then you have, or maybe you have some value here as well. So you dequeue the values and replacing them by X, and then head pointer will go and wrap around and it would go back to the first index. So that is what I'm doing here, and that is what we have to write. So it will return the next value. So the value that we're going to dequeue, let's call it deleted, and the deleted value would be Q array, and we'll get the value that's stored at the current head pointer. Okay, so whatever is the value is at the head pointer, we are going to pick that value. Then I'm going to increment the value of head pointer by 1. The reason is that the head pointer starts from 0, which means it already points to the last value stored in the queue. So if it had started from -1, then first we would have incremented 1 in the head pointer value, then we would have gotten out the value. But since it's already pointing to 0, so it's pointing to the right value. Okay, once we have incremented the head pointer, we again have to simply check for the wrapping around. We check if the head pointer at any point becomes greater than or equal to 9, that means it hits the boundary of the queue. Then we are going to pick the head pointer and we're going to bring it back to the index 0, meaning that there are more values that can be deleted. And we simply have to return the next data item in the queue, and I'll just try to return the deleted value that we stored here. And we also have to decrement the number of items because we have removed one value from the array, so that should be updated by reducing 1 from the current number of items. So if right now we had 8 items, they'll be left to 7 items. And this is a complete dequeue code. Now in the last step, they're saying that you have to write the main program, and we are supposed to take 11 input strings from the user, use the enqueue to add each statement to the queue, output an appropriate message to check whether it was added or not, and call dequeue twice. Okay, since there are 11 values, it should give the error on the 11th value because 10 is the size of the queue. Okay, so we'll run the loop for I in range 11. I'll ask the user to add the, let's use the same parameter names, although you can change them. These are supposed to be string values, so we won't wrap this in int. Enter q value maybe, and whatever the value is, we are going to add it using the enqueue function data to add. And if we remember, enqueue is going to return either true or false in Boolean form. Then we have to check if the response is equal to true, or if I just leave it like this, I can print something like data to add was added to the queue like this. And if the response is false, then you will print the opposite. You'll say that data to add failed to be added to the queue. Or you can write any other message of your choice. Okay, once this is done, then they're saying call dequeue function twice and output the returned values each time. Okay, once the loop ends, we are going to call dequeue twice. Let's call it deleted value 1, which is going to be called using the dequeue function. And then we'll have deleted value 2, which is also be going to get called from the dequeue function. And then we have to output the returned value each time. So we'll say, again, you can print something of your choice. Del1 was dequeued from the queue. Similarly, delq was deleted from the queue. And then they're saying you have to test the program with these inputs. So let's try that. So when we are adding the values in enqueue, we are actually supposed to use all of these parameters. We forgot to do that. So I'll go ahead and I'll just paste them here. Q array is already defined. Then head pointer is already defined. Tail pointer is already defined. and number of items is already defined. So these are all the global variables that we are accessing here, right? And we are just going to use them now, and let's see. And we need to access all of these variables globally: QArray, head pointer, tail pointer. Since these are clashing with the parametric names, we need to change these names so they do not overlap with the parameters. Let's call this QA. Let's call this HP. I'm just converting them to abbreviations: number of items and data to add, like this. Because these four variables already exist. We have the QA, number items, tail pointer, and head pointer. So I'm going to access them globally, and data to add won't be written here. Okay. And I think everything else is fine. Data to add will be stored here. And similarly in DQ, we have all the variables accessed there. And yes, should work now. Yes, so it's working perfectly. We added all the values from A to K. And since A and B were the first two values that were added, so when we DQ, so A and B were DQ'd from the queue, and the question is done.